Greetings, friends. Welcome to another video. Let's get into it. So tonight I'm going to take you through an experiment I've run with ChatGPT's Code Interpreter. So the setup of the experiment here, we're going to take data from Makeover Monday from their FDA product recalls dataset. It's roughly 13 megs, Excel file, 17 columns, about 83,000 rows. And we're going to run 4 prompts against that, and we're going to run them 5 times each. So we've got these 4 different prompts. We've got what I call the basic, the perfect, the step, and the creative. So the basic prompt is just provide me with your top 5 insights from this data set. Use charts as required. The perfect prompt, you're the perfect Python data analyst, possess a combination of technical skills, analytical thinking, and domain knowledge to effectively manipulate and interpret data. Provide me with your top 5 insights from this data set. Use charts as required. And the step prompt, provide me with your top 5 insights from this data set, use charts as required. Let's think about this in a step-by-step manner to ensure we get the best results. And finally, the creative. You are Creative GPT, an innovative and creative thinker. You excel at design thinking and providing creative insights. Please analyze this data set and provide me with 5 of the most creative insights you can find. Use the most beautiful and creative charts you can think of. I also ran a control with no prompt, but it doesn't provide any charts, just gives me the columns. So in order to do that, all you need to do is come over to ChatGPT 4, Code Interpreter, click Upload a File, grab the file you want, let it upload. So I've already prepared that control and labeled it here. And as you can see, all it does is ingest the file into memory using Python, and does some basic checks to see what the columns are and makes a guess at what each of those columns mean. So the goal of this experiment was to see the minimum amount of prompting required to generate good analysis. These results can undoubtedly be improved through further prompting and conversation, but this is just some rough ideas of how to do that. Once I got these results, I need to analyze the results. So I developed a scoring system for both the charts that were produced and the text. So I scored it a 0 if it did not work or there were no results. I scored it a 1 if it returned some results but they were wrong or unusable. A 2 if those results were at least partially right. This includes basic or ugly charts. And 3 were usable and accurate. Most of the charts from all of the prompts came out with this score. They were decent charts, they were correct, but they weren't special. And then 4 was very good, so these were interesting charts and accurate or in-depth text. And then 5 was exceptional or mind-blowing, but I didn't see anything that hit that level. So in overall results across all the experiments, the step prompt performed the most reliably, with the basic prompt coming in surprisingly close second, at least for the charting. I was actually shocked by how bad ChatGPT was at commenting on the very data it had just used to create the chart, where 70% of the text results were actually complete hallucinations. So here you can see some of the data that I put together in Power BI just based on those rankings. And you can quite clearly see that STEP here is performing best in charts and by a long way in the average text ranking. I also put the distributions of each of the runs here in these violin plots. So you can see the distribution of the chart rating. So the perfect prompt was definitely more unreliable in its outputs, although it did also get some higher results for the charts. And you can see here that the basic prompt had some of the worst text input, whereas it was pretty fine for the charting side of things. Step here, on the other hand, was kind of the most even distribution all up. It was also interesting to see that it didn't give the same recommendations on the insights each run. So I've grouped them here. They always gave them a different heading or name for the insights. So I manually grouped those up into kind of their logical groups. So you can see here, geographic distribution for the recalls, the reasons for the recalls by classification, by firm, product type and classification, the recalls by status, and then recalls over time. You can see here the darker is obviously more occurrences happening there. So now I'm going to take you through where I got the top chart and text result from, the worst, and then the most reliable. So we're going to go through the basic first. So this particular run was actually the one that had the worst chart and text in it. So let's just step through that. So first, you can see I've got that. Provide me with your top 5 insights from this data set. Use charts as required. And then it's ingested that file. That's fine. It's given these all the columns. And then to provide insights, we could explore. So distribution of recall classifications, most common reasons for recall, distribution of recalls across the product types, the firms with the most recalls, and the status of recalls, how many are ongoing versus terminated. Let's proceed with these analysis. It's then written all that out in Python here, and it's given us this big block of ugly chart. So here we have the chart exported. For this particular run, for some reason, it combined all of the charts into one, which makes it quite hard to see. So this is why I got such a low score for the charting. Not only did it not use any nice colors, it kind of jammed them all together, and we ended up with this schmozzle. So you can see here, although it's done some okay charting in terms of actually getting correct results and putting stuff on the page, we're not seeing that these axes are sorted. The colors are basic. There's no colors on here. You've got these huge long pieces of text here, and you've got this axis is not sorted. You've got this one is fine, I guess, just no colors. This axis is not sorted. I don't even know what this is. So we can see here, this is where the fun begins. So it's saying here the vast majority of the recalls are classified as class 2. If we come back here, yep, that's correct. So I got that one right. This suggests that most recalled products may have caused temporary or medically reversible adverse health consequences. So that's fine, got the first one right. In fact, this was the most common question that ChatGPT actually got right when it was writing about, which is quite interesting. I'm not sure why. Then we've got the top 10 reasons for recalls. So it says the most common reason for recalls is due to undeclared allergens, followed by microbial contamination. So let's go check that. Hang on a second. Yeah, I can actually see you've got lack of assurance of sterility. The product may contain undeclared milk and then microbial contamination. What was the last one it said? Or the first one? Undeclared allergens. Is that even on the list? It's not even on the list. So I'm not sure where it's got it. It's just completely hallucinated out undeclared allergens. Then number 3 here, we've got the distribution of recalls across product type. So the product type with most recalls is food and cosmetics, followed by drugs. Let's have a look. So just scroll down here. Food and cosmetics, no, that's second. Devices is clearly in the lead. And then drugs is second, but why is it skipping devices? Not sure. In my further experiments, I found that this was just a complete hallucination all the time. So even though it got the second and third one correct, that's just luck. Then we've got the top 10 firms with the most recalls with the most recent, with the most recalls being Hy-Vee Incorporated, followed by Abbott Nutrition. Let's go check that one. None of those are even in the list. So if we have a look here, it's clearly this Zimmer Biomet Incorporated, and then One Blood Incorporated, then Customed. So once again, completely hallucinated. This was something else that was hallucinated in all the runs. I don't think none of them actually got it right for whatever reason. Someone in the comments suggested that it was potentially the data set was too big and it was getting lost when it was trying to compare these things, but for whatever reason, completely wrong. Then we've got the status of the recalls. So it's saying the status of most recalls is either ongoing or terminated. The number of ongoing recalls is slightly high, suggesting there are many issues that are still being resolved. And once again, I think it's quite wrong. We've got the terminated status being by far and away the highest, with ongoing admittedly being the second highest, but it isn't close like it's suggesting here. It said that ongoing recalls is slightly higher, so it even thinks it's bigger. So as you can see, although it gave some charts and it did give at least this text correct, the rest of it was just a complete hallucination. So now we'll step into the run that contained the best results. The best chart and text result that I had in total. So this one here. So this was from my FDA Creative 3 run. So you're a creative GPT, an innovative and creative thinker. You excel at design thinking and providing creative insights. Please analyze this data set and provide me with 5 of the most creative insights you can find. Use the most beautiful and creative charts you can think of. Same as the previous data set, it loaded it in, spat out the columns. Then it suggested that it's going to look at the distribution of the product types, the most common reasons, the trend over time, geographical distribution, and then the classification of recalls and their distribution. So first, it goes and checks the product types, says it wants to use a circular bar plot to visualize this. For this, we need to calculate the number of recalls at each product type. So it did that, that's fine. It spits that information out. Next, we'll represent this data as circular bar plot for creative visualization. However, it's not going to actually produce it for me. So this lost this run a lot of points. It was obviously you're going to get a 0. It's not producing the chart at all. Sure, this may go and create it in a local environment. I haven't run this. This wasn't part of the experiment. But for some reason, it's decided it can't render that to this chart in the browser. So now it's going to move on to this word cloud. Now these word clouds showed up in several of the runs. Let's have a look here. Word cloud. So we had 8 out of the total runs that actually had a word cloud in it. It looks nice, sure. Not that descriptive, really. It's kind of hard to understand what the ratio or how big, but it is an interest piece. The thing that it always got wrong in all of the runs, whenever it did a word cloud, was it just completely hallucinates the data down here. So it says the keywords that stand out include product, potential, presence, contamination, may, labeling, incorrect, and lack. And from what I can see, you've got blood product, distributed blood, potential, contaminated. So it's got potential. I can't even see presence. So once again, text doesn't really make any sense. Then we've got this third insight. Let's examine the recalls over time. We'll create a line plot. Then you can see here, it's going to run it and it's made a mistake. So it's picked up that mistake, the syntax error due to the space in the column name product type. Let's correct and try again. And then it's given us this interesting chart. This was the only run that also had this line chart broken up by product type. It's not very clear. It would be much better if it was like a rounded trend, something like that, and if the colors were more diverging from each other, because right now it's nearly impossible to separate biologics, I'm assuming that is, but is it food and cosmetics? I don't know. Anyway, it was interesting that this was the only run that split it out like that. And what have we got in the text? We've got the number of recalls for all product types fluctuates over time, sure. Some periods having more recalls than others. It's like a horoscope. It's the most generic stuff you can find. It says the device's product type consistently has the highest number of recalls throughout the period. Well, that's great because it's correct. The tobacco product type has the fewest recalls, barely visible in the chart. Sure, so that matches up with my expectations from some of the other charts as well, so that's great. And then for the fourth insight, they want to do the geographical distribution of the recalls. So they want to have a look at the recalling firm state. And here they wanted to create a heat map of the United States. But once again, it couldn't render it. So it wanted to produce a chloropeth here, which would have been great if it could output it, but it didn't. Then we're moving into the recalls for the 3 different classes. It outlines what the classes mean. That's great. And now this is one of my favorite charts that got produced throughout all the different runs that I did. And it's a stacked bar chart. It was something that they stacked column chart, sorry. It was something that didn't appear in any of the other runs either. So this one just happened to be an exceptionally creative run, but it clearly shows the split of the different classes by the different types of products. So you can see here your devices are split. So you've got class 1s here, 2, and then 3. And then with food and cosmetics, you can see you've got the most in terms of the class 1. So they're the most serious ones. That would be things like food poisoning and stuff like that, where people got quite sick. And the other interesting part is that it also got this right for once. So none of the other times when we're talking about the products in the charts has it given us, well, I just know from memory that it always gets devices wrong and never puts them as the highest number on the recalls. But in this case, it's kind of calling out food and cosmetics have a significant number of both class 1 and 2 recalls, which is just what we talked about. Most of the recalls for biologics are class 2, which is also correct. Veterinary products are a relatively balanced distribution. Sure, I mean, class 3 is much smaller. Oh, it's just class 1 and class 2. And all the recalls of tobacco are class 2. Well, you can't even see any. Class 3 recalls are considerably fewer across all product types, which is also true. And great to see that I actually got something right. So that's the creative prompt. So we got some missed opportunities and we got some really nice charts out of the creative ones. And then for the most consistent. So this is the step prompt. So provide me with your top 5 insights from this data set. Use charts as required. Let's think about this in a step-by-step manner to ensure we get the best results. So as with all the other runs, it loads it in, outputs all the columns, and then it starts to perform some exploratory data analysis to gain insights from the data. So you can see here, it's actually checking the empties, the nulls, and then saying it's fairly clean, only one missing data. And then it's saying it's going to do product type, recall status, product classification, geographical analysis, and time series analysis. So let's start with the first insight and break down the product recalls by type. So you can see here, I'm not too sure about the color scheme. It's clear, but it's a bit drab. But it's sorted the axis as you would expect. We've got different colors for each of the categories. And we can see here devices, food and cosmetics, and drugs. Unfortunately, it's got it completely wrong still in the insight in the text below. So it's saying it's evident that food and cosmetics is the product type with the most recalls. It really surprises me that it gets it this wrong. I thought it would be able to be self-referential and look at the data that it was actually charting with, but it just seems to forget it and make up whatever it wants to say. Yeah, it's truly surprising. I certainly hoped for more from Code Interpreter. Now, in some other experiments that I'm doing, there are ways to get around it, but I would hope that as things get better, this sort of thing will just come out of the box and we don't have to risk having incorrect results just spat out to us really confidently. Now, the second insight, so we want to look at the status of these recalls. So we've got terminated, ongoing, and completed. Once again, sorted, colored, clean, nice. So it's saying the majority of the recalls are ongoing. Once again, I don't know how it's getting that. The terminated recalls are those that have been resolved or closed, and there are considerably fewer completed recalls, which is true, but consistently across almost all the runs, it was saying that these terminated recalls didn't exist. For some reason, it's always just going for ongoing and discounting the terminated. Then the third insight, we're looking at the severity of these recalls. So as I said before, this one, pretty much all the runs got correct in the text, but you can see here, at least it's ordered, it's got a nice color, it's a clean chart, that's fine. And then we can see here, class 1 recalls the most serious, fine. So the bar chart shows the majority of the recalls are class 2, suggesting that while these products may cause temporary or medical reversible health issues, they're not likely to cause serious consequences. Class 1 recalls are the second most common, correct, and then followed by class 3. The chart matches the text, great, on we go. So now we're going to have a look at the top 10 states by the number of recalls. Once again, we've got a nice chart. It's been sorted. We've got different colored categories. But then once again, you'll see it starts to hallucinate. For some reason, it was always getting California right. I'm not sure, maybe inside the data set, California appears first. I don't know why the data set was right with California, but then it seems to just hallucinate the rest of it. So in this case, yes, New York and New Jersey are on the chart, and then it goes Florida, Texas, and Pennsylvania. So all of these are on the chart. I think that's okay, but you just don't have faith that it's doing the right thing, because it gets California right, but it's not followed by New York and New Jersey. It needs Florida and Illinois. So finally, we'll move on to the fifth insight. This was another one that was pretty common with the line chart, looking at the number of recalls per year. Just a basic line chart. It shows the trend, sure, but it's not a very pretty chart. I'd love some data labels and something maybe a little bit smoother. But in this case, we've got the line chart shows the number of recalls per year. It's clear the number of recalls has been relatively stable over the years, I guess. However, there seems to be a significant drop in the number of recalls in the latest year, 2023. This could be due to incomplete data for this year, as the data set might not include all recalls for 2023. This is about as good as any of the runs got with the time series analysis. Some of them straight up said that it's clear that the trend has been increasing over time, which is incorrect, but this was pretty spot on. So just including some of the other collection of the common charts you'd see. So we've got distribution of product recalls. This is probably one of its favorite color schemes from the Seaborn library. The number of recalls over time, the top 10 firms, and then this word cloud. Well, I hope you've enjoyed my little experiment tonight. I've been both simultaneously impressed with the charts and the code and disappointed at the same time with the text during these experiments. I think from here it will continue to get better. And in my next experiment, I'm going to be taking some of these more successful prompts that we had here and extending them to see if I can get them be accurate with the text and reduce those hallucinations that we've been seeing through this experiment. Hope to see you in the next one. Have a great night.